G'day guys. Got a GP Extreme that had its front end blown out, and I'm going to rebuild one of the channels as one side's working, one side's not. It actually took out the op amp as well. So a lot of things went up in smoke on this, and first of all, what it took out, this detector had these devices as the first input MOSFET. I'm going to grab my little headset here so I can have a look at the numbers. There's a lot of these came out with BSP121s. Later ones, I think, came out with ZVN2120 devices. All the devices I mentioned are fairly high on resistance devices. They're not that good. So one of those is fried, and I had to, I can't leave a high resistance device and a low resistance device in the circuit. It'll be unbalanced, so I have to replace both. And what I have to do now is replace the ZVN2120 with a 2SK1334, which is a much better device, which are used on all the newer detectors, such as the 4500s, 5000s. Now, when you put these on, you have to be careful. I'll explain it after I put it on. I'll just tack it there for a minute. On these boards, there's circuit tracers that are under the device. You must have the device pointing on a couple of degrees upwards. If those circuit tracers touch the metallization on the back of the MOSFET, it'll go bang, it'll cause smoke. So you could put a small insulator there, like a little bit of mica or silicon sheet or something. But if you just angle them upwards, it's not going to hurt. The other thing as well, which I should mention, on these detectors, this capacitor lives under here. There it's 2 pins right next to that 5 volt rectifier. Well, that's on the 5 volt rail. That's a Schottky diode. That's on a 5 volt, negative 5 volt rail. That's your rectifier diode for that. And these 2 points here, that one there and that one there, always short this capacitor out. And if the detector's been on, it'll get snap, crackle, pop when you do it. But if you don't short this capacitor out and you touch the MOSFET legs to ground or anything, even just soldering these on, 9 times out of 10, it's going to pop this little transistor here. This is your MOSFET driver, okay? And if these don't switch, usually it's this. It's a BC 587 for memory. It's PNP anyway. Just a high gain PNP transistor. Anything 20 volt rated, 30 volt rated. It's not anything special, as long as it's got relatively high gain, and it's rated. Well, it's not going to switch half an amp, but the more you can switch and sync and source current through this device, the quicker you can turn your MOSFETs on and off, which is better overall, because it's in a signal line. You want these things held hard on receive, and when you've got the back EMF, you want them off, and you want to turn them off hard. You don't want any leakage there. That back EMF flyback voltage will take them out. So that's the initial thing you got to do, short that out, and then you can replace these devices. Anyway, I have done the other one previous. I'll just tack the rest of this on. Don't worry about blobbing too much solder. The thing is, they were made for bigger transistors or bigger MOSFETs, and you just got to bridge the solder up like so, just so it's on. If you want to heat it, the tab at the back on the top of the transistor, which is facing away from me, you can tin that up. You got to do it very carefully. Tin it up and just blob the solder on the pad at the back, like I've done. You can probably see it pretty clearly. I'll do it on this one as well. There we go. That's a little bit of heat sinking for these devices. They don't get really hot. Now, the other thing that it took out when I opened this up, there is a little protection diode here. It's a BAV99. It's one of the smaller ones. And I have to replace that. And my tweezers have become magnetized, and the little devices want to stick to it. So I'm going to have to demagnetize that. I want my real pointy tweezers. I've got some over here, something very small like so. And I'm going to attempt to solder this little tiny BAV on there. Yeah, it's even sticking to these. Everything here has become magnetized. I don't know why, but it has. So what I'll do, let's fix that pad up there. It's got a bit of high blob on it. I'll go over the whole repair of this because it went through it like lightning and took a lot of things out. So I'll just tack that there. Now heat it up and push that down. It did have a little bit of a mound of solder on the legs there, but like so. You don't want to heat these up too much. They're very, very small. So this one, the rest of it's okay. I've gone through and checked. That device there, I think is okay. I should actually check it because the transistor this side did go short circuit. It might have caused too much load for it. So we'll check that if I get through the white paint here. Okay. Make sure it is definitely still a transistor. If you have your multimeter on diode range and put it on. Yeah. If you got this around the way I have, I'm actually testing it in the reverse polarity just to make sure that its internal diode hasn't gone short. But normally you test it the way I've got the meter leads now. Okay. From base to emitter, it'll read 100 ohms because there is a resistor across it, 100 ohm resistor. If it's actually an open circuit, you won't know because the resistor will give you that 100 ohms. And we'll go to the collector, 647, or should I say 0.6. If you wiggle it around, you get a different bit of a reading, but about 0.6 something of a volt across there. That's okay. That's survived. you can always check the MOSFETs. Yeah, 582, a little bit of circuit loading, just drain to source. Yeah, same. If you get the same value, 580, 6.6 or so like that, they're probably okay. The other one was dead short circuit and sitting there frying. Now, on this, I'll just get up and check the camera, make sure it's actually pointing at the board, because it's no good doing this work and you can't see. Okay, we're still at the board. I'm not zooming in too far, because what will happen is I'll move the board this way or that way, and you won't know what's going on. So if you want to see it, you have to zoom in yourself. If you use a computer or something like that, you can zoom in. Okay, the other things that were fried on this op amp was taken out as well, and I put a AD797 in there because they're a far better op amp. I thought it did have a AD797, because they're all ground off and covered with white paint. You don't know what they are. It's very hard to tell. There is a slight difference in the pins if you check it with a multimeter, or otherwise you've got to put it on a circuit board and test its noise figure, and that is just too tedious. So we've got one here, that's okay, but I have replaced this one. It also took out this what's the part number again? BF 908 here, and you can't get BF 908s anymore. They're a discontinued line, and you still can get, if you're very, very lucky, which are also discontinued, BF 998s. They're a little bit different, but they actually work perfectly in the circuit. I've tested them. There is no difference. There's a little bit of difference in the voltage rating and the transconductance. Doesn't make any damn difference, right, in this circuit. So I had to put a new one of those on there. You can see that one there. It's black. Anything black is what I've had to put on. And also it's taken out the P-channel MOSFET and the other protection diode. So when that N-channel device went short circuit, it basically shoved 200 odd volts back down and took everything out along the way. So I have put a AD797, but in my hand, I'll do this up near the camera. I'll show you how to tell what's an AD797 and what is not. So we've got that there. It'll come out like that, just painted white, and you'll think that it's an AD797. Whoops, where am I? I'm getting a bit too close. But if you look at the back of it, I don't know if you can see. I don't want to get blurry, but if you can have a look there, there's a little circle on the back of the IC. I'll just wiggle it around a bit so it's fine. That little circle, right, tells me that it is not an AD797 that was in there. That is a NE5534. Now, the NE5534 has a noise figure of about 3.5 nanovolts, and the AD797 has a noise figure of 0.9. So there is a big difference. If you have got the NE5534s sitting there, that one there and that one there, you flick them out and put AD797s, but you have to remove them to know what they are. It's very, very difficult in circuit to work out, is it that one or that one, because just a noise difference in each circuit board, just component tolerances, your environment. You're not going to be able to hear it, except if you're out in a quiet environment on a goldfield, it'll make a difference, right? It'll actually hear targets that are hidden in the noise of the 5534 devices. It might be the difference between hit and miss on digging a target. So, you know, these older devices should be given the flick, and the new ones in. Now, because that one was a NE5534, that one there is also an NE5534. So I'm going to have to replace that one as well, or else the detector will be unbalanced. And the reason being, it combines both of the outputs of these operational amplifiers in mono mode. It uses them, it parallels them in the multiplexer. And in DD mode, it only uses one, and the other one doesn't do anything, and that's also switched out in the multiplexer. So that's that. Now, what I've got to do here, I have to get a tiny little BAV99. I've got it sitting here. All these tools are magnetized at the moment, and the best way to unmagnetize tools I have found is get something and just whack it, and hopefully that's got rid of that magnetism. If you bang, you know, I don't mean you can't go and bang proper permanent magnet. It's not going to lose. It will lose some magnetism. It's not going to lose a lot. But on something like this, which is meant to be stainless steel, yeah, they stick. Now, this will be interesting because after I've tapped it, it is not sticking anymore, if you can see that. So if your tools get magnetized, just bang them really hard, and that'll get rid of the magnetism. So we've got to put that back around that way, and you don't get the position of this and the P MOSFET around the wrong way, else you'll have smoke. It'll take out the N-channel device, and it'll blow it all up again. So we don't want to do that. So very carefully, get in there. Okay. Push him down. You go leg to leg. Usually if you're taking them out and you haven't used solder wick to get the board completely flat, it'll stick up a fraction of a millimeter, and just going to make sure that you just connect the legs. Don't worry if you put a bit more solder on than normal. It overall makes a better electrical connection, even fractionally, but it does. So we've got that in there. Now the device, I'm going to change the other P channel to a better device as well. The P channel devices in here are BSS184. For memory, they have a fully turned on resistance of about 10 ohms, and that's about the same as what those ZVN 2120s are. So having that in the input stage is 20 ohms of resistance. A little tiny signal has to overcome, and part of it's going to get lost in that resistance getting into the op amp. So get rid of all these high ohmage components. The other part of it with using low ohmage components, you've got to be very, very careful of the gate capacitance of the device and all the other, reverse transfer capacitance and all the other little intrinsic capacitances in the device, element to element. The reason being is that, you say, okay, gate capacitance. Well, what's the gate capacitance in relation to? It's in relation to the other elements. And if you've got a signal coming down, which is going drain to source, or whichever polarity you run these things, source to drain, should I say? what happens is that the signal couples through both the source and the drain to the gate. And that is just basically the gate lead through its electronics eventually has to have a discharge path to ground. Even when you've got voltage there, it's a flow path, and your signal's just going to look at that and go, oh, well, we've got 200 picofarads of capacitance there, and your signal's going to go straight through that capacitance and just leak off. So you're going to lose signal. You've got to use devices, the lowest gate capacitance that you can get, and take into account its on resistance as well. You've got to match all these parameters to get good performance. You can't just go and stick some resistor in there, 50 milliohms resistance or something, and say it should be right, because it's going to have gate capacitance of about 280 picofarads, and say goodbye to your signal. It is all trade-offs, but it's how it works. Okay, now what I'm going to do, I'm going to get one of my, I'm going to do both of these now, but I'll just do this to prove that I have repaired it and checked it, make sure it all works. We'll get my Special K. These are a really, really good PNP, PNP, P-channel MOSFET. My God, I've got bipolar on the brain. I'm going bipolar. How's that? Here we go. Oh, I've got a bad habit of calling MOSFETs transistors, even though technically they are, I suppose. So he's in, just about. You've got to be careful sometimes. You think you soldered them in, you haven't. Okay, so we've got our BF 998 AD797, the BAV 99, the low on resistance, low capacitance P-channel MOSFET, the 2SK1334 on the other side of the board, and the BAV 99. There's another, there's two BAV 99s I've replaced. One's on this side of the board, one's on the other. Now what I'll do, I'll get, just to prove both channels are working, I've got a figure 8 cancel coil here, which is, it's come unsprung actually. Don't know how much it's going to cancel, but it'll fire up both channels at the same time in parallel. It would do, but it just fell off my isolating stick. Have I got some? I need some tape to do this, and as I said before, with the cleanup of the workshop, it's very hard to find anything. But over here, what have we got? Okay, yeah, I found some masking tape. Good, just some masking tape. I'm just going to tape my figure 8 coil back into a figure 8. It looks a bit sad at the moment, so I'll do that and I'll tape it onto the stick. Okay, I'll try and get this as accurate as I can. Round you go. So this is just a flexible mono which you bend into a figure 8 shape, and that allows getting rid of a lot of the interference coming in. Okay, I've got that. I have to tape it to the stick because I've got it jammed in the drawer on about a 45-degree angle that wants to slide down to where all the metal is, and that's not going to work. So get some of that. I'll just tape it on top, and hopefully we'll be able to get somewhere. So okay, I've got the cancel coil hooked up. Make sure no wires have popped out, no short circuits. Turn on the amplifier, and we'll turn on the switch and we'll see if this thing works. Hope it does, unless the other channel's damaged. We'll find out. Oh, we have noise. Okay. Sounds like it's working. Oh, hang on, it's in cancel mode. Silly me. And that's, yeah, it sounds alive. There you go. These are confusing. The reason being, I've got an electric heater on over there. It's picking up the fan. But anyway. Oh, this hasn't got. I'll just let it do a frequency scan. But even so, I've got to change the P channel. Let's turn that down a bit. I've got to change the other P channel out to the same one, and I'm going to change the 5534 to an AD797. This will end up being a very good detector. The GP Extremes are actually a very, very good detector, very sensitive, and you really need to redo the front end on these detectors to get the full benefit. You know, I think some do have, later ones have AD797s, but the P channel FET and the N channel FETs need to be flicked out as well to better devices. Currently, I'll get this worked out. Let me have a look. We got, instead of having, it's still noisy. It's just that I've got this coil very close to a heater, and I move it away. Yeah, but then it's going to come near me. So I've moved it away. It's a bit quieter, but still typical. A figure eight coil, even the way you make a figure eight coil, because the lead comes off, and there's pickup on the lead, gets back into the coil and unbalances and goes nuts. And I'm just checking to see if anything's getting hot. Cools a cucumber. No smoke, no burning smells. So that also that proves that the little BC5 587 driver to the gates of the N-channel MOSFETs is quite okay as well. It's working fine. So we'll just check this for sensitivity. I'll use a 0.1 on this coil. Works like a charm. I'll try to 0.05. Yeah, I have to touch the coil. I can just get that. So this is working. We can do a ground balance. I have a Kalgoorlie hot rock here. So we'll just give it a quick ground balance. We'll just check that out. And we go fix to track, back to tracking to give it fast tracking. So that, yep, ground balance that out straight away. So that is how you repair one of these detectors. It's very common on these detectors. You open it up, you'll smell a burnt smell, right? Let's make sure that that's still on view. I'll just zoom in a little bit. Make sure I don't touch anything, cut myself off. I've done a couple of videos, and when I've zoomed in, I've actually put my fingers too far across trying to spread the screen on the back, and with because it's a touch screen, and I've accidentally hit the stop video button, so I've got to get up and actually look at what I'm doing. So okay, that's good enough. I don't know if I can get in any more than that. That's it. That's pushing it. Okay. So what happens? You get your detector, it won't work. It either won't turn on, or it'll sit there and make horrible screaming noises. And it may work in double D, but it won't work in mono, because, like I say, one of these is on the input for double D if you're using a double D coil, and the other one's on the input, which is switching the voltage to the coil, the main drive coil, the transmit coil. So the main transmit coil is where you got your flyback, and I think for memory it is this one here. Is the one that cops the flyback, and this one here has just a signal, the low voltage from the double D. If you're only going to use double D, I'll tell you a secret. If you're only going to use double D coils, right, and never ever connect a mono to it, because it'll blow it up. You can get rid of this transistor. You can just take it out of circuit and short it where it is, drain to source. You can go onto the PFET, short that out as well, flick it out of the circuit, and you have no resistance, no resistive or lossy devices in that receive circuit. It's on low voltage. It doesn't care. It doesn't have to cop that massive big flyback and block it, right? But if you do that, the detector will work better, but you're limited to using double D coils, and you cannot use a mono. You can configure it to use a mono, but there's no benefit in doing it if you're going to use a mono. You're better off, when you use a mono, you're better off having the two channels in parallel, because you technically get a 3 decibel improvement in noise figure by combining the two channels together. So yeah, I wish I didn't say that now, because someone's going to do it and blow their detector up, right? That's just the way it is. But as an experiment, you could do that. Yeah, but I know it'll happen. Someone will borrow your detector and stick a mono coil on it. That'll be the end of that. But it's a good way of if you're using fairly decent sized double D coils, looking for big deep gold, really fringy type gold. Yeah, you can get rid of the active devices on the receive coil of a double D. Just remember that you still need to block the high voltage from the back EMF from the coil, from the transmit coil inside a double D coil, right? And that's what the other one does. It'll block that, and you just put that to the receive coil. But that's that. Now, what I was saying, when you open these up, usually if it's gone crazy, you'll see because these are colored, you're covered in white paint, you'll see a discoloration in the paint. It'll go a brown color, or it might be charcoal black. I have had these before where it's turned into a glowing ember and burnt into the board, burnt through tracks, made a complete mess of it, carbonized the board. It was nearly a throwaway. I had to sit there and pick out all the carboned fiberglass, and then I had to resurrect the track work underneath. There was about 4 tracks burnt through. The other thing too, then I had to fill it up with fiberglass resin or an epoxy. You can use 2-part epoxy. Get it all nice, straight. Put your wires across again, and then hopefully solder your devices in. Hopefully it works and there's no carbon you've missed, because with the back EMF voltage sitting up around 200 volts, it's going to arc out eventually. It's going to have a little conductive path. It's going to arc out. It's going to burn the board again. So any carbon around here, or any dirt or build up that can go conductive, will take your detector out eventually. Make sure it's all clean, and that's a good thing to cover it with that white paint, because it's totally high resistor. It was basically an insulator, and stops anything getting in there. So on this one, the AD797 chips now are damn expensive. If you want to buy one, I think if you want to buy it through DigiKey or Mouser, they want $28 each for them. And I don't know if that was Australian or US, but AD797s had gone right up in price. Just like everything's gone up in price. So I do have to take this out now to make it the same as that. I'm not going to, for this customer, I'm not going to go and say, oh, I'll stick another noisy old 553 and 4 in there. That's not fair. And I'm going to change the other PFET as well. So that is one successful repair. Now I've got to put some other videos up. Now these were going through nicely, and then it got cut off. But there's still a lot of info in there. One of them was a repair of an SD2000, and yeah, there's another one there too. I can't remember what it was. Oh, it could be a GPX or something came in. I've had a couple of 7000s come in for the upgrades to get rid of the noise out of the circuit, and that has been really successful. The feedback on that is really good. As you can go and read the feedback on the other videos, what people have put up after I've done their detectors. You know, it's funny, this gold business. When you well, it used to be this way. I don't know if it still is, but I used to when I used to do up people's detectors, they used to keep it top secret. They used to put covers over the front so no one could see the extra controls. It didn't want anyone else finding out there was modifications for the detectors, thus going out and getting the gold that everyone else had missed. So that's quite funny, some of the stories on that. You got to remember, I've spoken to many hundreds of prospectors over the years, and yeah, and some of it's quite hilarious. But Dave does that now. Dave mans the phone, because if Dave wasn't manning the phone, I wouldn't get any work done. I'd just be on the phone all day. So that's not a business. That's the civil service or the civic service. I don't know. Yeah. So anyway, that's that. And anyway, I'm not going to do a video out pulling these out. All you do is scrape all the paint off the legs, heat it side to side, flood it with solder so it falls off the board. Don't rip it off the board. You'll rip all the tracks off, and it's a nightmare to fix. So you can do it for hot air. Actually, just for the hell of it, how about I do one? I do one for hot air. I'll take the chip off with the hot air. Right now, I've got a fairly good flow rate on this, and because they've used non-lead solder, you've got to crank the temperature up a bit. But I'll give this a cook. I'll try and keep everything away. You've got to be careful doing this. You can start heating up the other components. Not a good idea. And you want something, give it a bit of a poke. So when you do this, you don't need to go and scrape up all the legs and flood it with solder. Just hit it. It's going to be thrown in the bin anyway, so it's no good keeping it. 5534 is a very old component, old technology. Hope you can still see this. I don't know if you can. I better check first. It's here we go. Stick it in the middle of the screen a little bit. Okay. You heat him up. The paint will go brown. I just go quickly one side to the other. I don't know if you can still see it, but we'll see how we go. Okay. There we go. Straight off. Oops, it's on the floor now. Get swept up later. So as you can see, I take it you can see that actually came off very well. Some of them are glued on with paint. I can't zoom in any more than what I am. Damn. Yeah, okay. We're still going. So yeah, that is how it come up anyway. If you zoom in on that, if you want, it's very clean, and there's no paint build up or anything. I can just put the other chip straight on, and I've got to take off this one as well. Should have actually done it at the same time, but I'll do that in a second. But that's how easy or how difficult it is to do. Because everything's covered in white paint, you don't know what the parts are. You have to know what the parts are. You can't just replace them with anything. It's not going to work. Some of it's critical, especially where the signals coming in. You don't want to lose your signal via high capacitance element to element on the MOSFETs. And if you didn't know that BF 9908 that they did use in these, which are no longer available. If you didn't know you could replace it with a BF998, you'd be up, the proverbial creek. And the BF998 is made by Siemens, by the way. So, well, they've changed their name, haven't they? Infineon. Yeah, they're hard to get. They're like end of life, last production. Put your orders in, you're not getting any more. On those, what are they? There's just some BAV 99s. There's some FETs. I don't know how many I got. Oh, here we go. As you can see, I got a end of life reel. So I bought a. Oh, there we go. I bought a reel of them. I think it's 250 in there. That should last for doing repairs. And yeah, like I say, they're hard to get. So if you're going to do repairs on these things, try and stock up now, because I got caught out with the BF908s. They just vaporized, and they were there one day, gone the next. Try and buy them. There's some on eBay, and there's people trying to sell them for like $10 each for something that used to cost 50 cents. So that's what happens. You're going to get absolutely reamed over it, for a better word. Anyway, that's enough of that. Hope you enjoyed that. How to fix the front ends on these. The other thing that goes wrong on these is in here, that as an N channel, I think it's 3.5 amp MOSFET. If your detector doesn't turn on, these things go black and crispy as well. And you can put a new one in, or the other way, if you want, you can take it out. I don't recommend doing this, but it's a quick and easy bush fix. The on-off switch wires, put it on the wire, and it doesn't matter which way it goes around, on the middle connection, which is the drain connection, and on the last connection this way, which is, drain and then source connection, and you can actually switch it on and off with the switch if that ever blows up. But eventually it'll take the contacts out of the switch. It'll start pitting them, and they'll burn after about 1,000 switching operations, or maybe 100. I don't know. I haven't done one to failure, so I don't know. But it will get you out of trouble, and you can do that, or you can just put a solder blob between the two last ones on that MOSFET in there. That's that thing with the 3 legs. And just short it out, and you can just plug your cable in and out to turn the detector on and off. Like I say, these are bush fixes. If you're out in the middle, of the Pilbara in WA, and you might have a campfire, an old fork, and a bit of solder. You can blob it, and preferably you got a screwdriver as well, so you can take the thing apart and do it. But there's a lot of things you can do out in the bush, quick and nasty fixes to get these detectors working, even on the any of the GPXs, and probably even on the GPZ as well. Depends what it is, but there's things you can bypass to make it work. So keep that in mind. There's other things that go wrong with these too, but I can't do all that in one video. I wait for them to come in for repair, and I'll just repair it like I'm doing now, and I'll just talk it through. So hopefully it helps some of you guys who've got dead detectors. Catch us later.